Okay, right students. Now we discuss maxima and minima. Okay. So what is the maximum? Highest value is called maximum, and the least value is called the minimum. Okay. A function f in the interval I is said to have maximum value if there is a point C belongs to I such that f of C greater than f of x for all x belongs to I. Similarly, for f of x has minimum value at C belongs to I if f of C is less than f of x for all x belongs to I. Now see here all of you, we are discussing the part of maxima and minima, right, for a given function. Already you know what is maximum, what is minimum, right? There is a function defined in the interval I. I is a closed interval, okay? And we are locating a point C belongs to I, right? C must be part of I such that f of C is greater than f of x. Then let C the function has maximum value. If f of C is greater than f of x, is less than f of x for all x belongs to I, okay? Then C has minimum value. So if by the above, we'll discuss it clearly. Just this is a definition we are discussing. If f of x has either maximum or minimum value at any point C belongs to I, then f is said to have, both are said to be extreme value or point C in I. So again I am saying you, f is defined over interval I. I is a closed interval and it is I belongs to f of x, domain is capital R, real number. Then if there is a point C belongs to I such that f of C is greater than f of x. What is f of C? Value of y, because C is x value, corresponding f of x like that. For a corresponding C, f of x has maximum value compared to other x's, other real number. I will show you graph. Then it has maximum value. If f of C is less than f of x for all x belongs to y at a point C, then it is called minimum value. If a function has either maximum value or minimum value, then it is said to be having the extreme value or extreme, that's point of maxima or minima. Just note down. We'll discuss it very briefly, very clearly, very thoroughly, so that it will be very clear. Just this is the definition. First, keep a note of this notation geometrically, and then applications we discuss very thoroughly. Okay. So we are discussing the maximum minimum of a function. Okay, defined over the real number R. The domain of the function must be real number. So it can have maximum value for any point C such that f of C is greater than f of x, or minimum value such that f of C is less than f of x, where x belongs to I and C is any point in the interval. Then it has either maximum value or minimum value. If the function has either maximum value or minimum value, it is said to be having the extreme value, that is nothing but the point C in the I. Just make a note of this. We'll continue this point by geometrically, and then applications, how to find the maximum, minimum, and what is the definition of increasing function, decreasing function. Geometrically we align those parts, and then we apply for the solving of problems. Just basic theory it was. Okay, please make a note of it. We'll proceed further. Okay, now we'll continue. What is the geometrical meaning of this? We'll see now. Right? There is a function like this. Okay? Right? C belongs to I. Right? F of x, the domain is I. Okay, f of x belongs to a real valued function. Domain is I, this is the interval, okay, this is y and this is x. Geometrical meaning, right? What is for maximum? C is a point in I, right? C is on x, f of c is this part, this f of c. It is a maximum value. Suppose c is a point of local maxima, okay? Generally maxima and minima are called as the maxima or minima of a function are said to be local maxima or local minima. So generally local maxima or local minima is nothing but shortcut, like how we call either alcohol as alcohol. Same way, local maxima and local minima are called maxima and minima. Are you clear? Now C is a point in the domain of X, okay, domain of F, and C has the maximum value because this you see, you can see here C is. So up to from here to here, this is C. This is C minus H to C. This is C to C plus H. Okay. So in the interval C minus H, because this left side of C minus H to C up here it is increasing function. So f dash x is greater than 0. F dash x value will be by derivative test, first derivative test. Now during increasing function, first derivative test, what is that? F dash x greater than 0. Now after reaching the C, highest maximum C. So what happens parallel to x axis? So f dash x is equal to 0. Yes. The max the tangent or derivative of the function slope is parallel to x axis. F dash x is equal to 0. Perpendicular x axis is equal to, it is infinity, you know already. So here f dash is equal to 0. After C again it is coming down. So f dash x less than 0. C belongs to C plus H. So there is the total domain of C, the neighborhood. This is the neighborhood, you know, the neighborhood of C as C minus H to C plus H for H greater than 0. So in the interval C minus H to C, f dash x is greater than 0 as it is increasing. And in the interval C to C plus H, f dash C x is less than 0 as it is decreasing function. Let us see f dash C is equal to 0 since C is the maximum point. Okay, the point of maxima or point of local, because C is inside now, that's called local maxima. And f dash C is equal to maximum value and C is the point of local maximum value. Okay, C is the point of local maxima and f dash C is the f of C is the maximum value. Right? So if a function is a combination of increasing and decreasing function, at a point C belongs to I, we have found f dash is equal to 0, then this is the maximum value. But in the interval, left side of neighborhood of C minus h to C, divided for h greater than 0, for small h. Okay, for arbitrary h, the interval the function is increasing. So automatically by first derivative test, what happens? F dash C is greater than 0, f dash x is greater than 0, x belongs to C minus h to C. Here x belongs to C plus h to C to C plus h, f dash x is less than 0, C is the point of local maxima. So at the point of local maxima, what happens? The left hand neighborhood is increasing and right hand neighborhood is decreasing. So otherwise what you can say, if a function is coming from increasing, converting from increasing to decreasing, the point is said to be maximum value. Are you clear? Just make a note of this. This is studying on geometrical interpretation. But again, we'll be solving the problems very clearly, right? Note down, geometrical. Only for your theory idea it is going on. Problem solving is very simple. Again, we'll go for two tests, like increasing decreasing function, first derivative test, second derivative test, like that. Just make a note of this. Similarly, we'll discuss the minimum value also. Okay. Can I go ahead? Note it? Okay, noted? Yes. Now we will see the different function, the reverse of that. We'll take the function like this. C is the point of local minimum. Okay. If C is the point of local minima as f dash C less than 0. Of C is minimum value. Okay. Now see here, see this is C minus h to C interval neighborhood. This is C to C plus h. Then what happens? This increasing function. So f of dash x is greater than 0. Here f dash x is less than 0. This part is decreasing and this part is increasing. Okay, and here f dash is equal to 0. Tangent. So what happens? The neighborhood of C as C minus for h greater than 0 in the interval, right? Okay. f dash x is less than 0 as it is decreasing. It is decreasing, and f dash x is greater than 0 as it is increasing. Point of local minima. So what happened now at C? C is the least value, so minimum value f dash is 0, automatically tangent. In the left side of C minus h to C, it is a decreasing function, f dash x less than 0. In the neighborhood of C to C plus h, total neighborhood is C minus h to C plus h, but divided with C, both sides, okay? So it is increasing function, decreasing. So when the function has set to be local minima, when the sign of the function changes from negative to positive, then minima is there. From positive to negative, that is called the maxima. Automatically when you reach the highest, you will come down only now. So positive to negative, then it is the maximum height reach. When negative to positive, you have the approach to the least height. So when negative to positive, the sign of the derivative of the function changes from negative to positive. At that point, the function is said to have the local minima. And the sign of the function changes from positive to negative. At that point, the function is said to have the maxima. Where the point has minima, that is called the point of local minima or maxima, and the value at that point is nothing but local maximum value or local minimum value. Note down. If the function has either local maxima or local minima, it is said to have the extreme value at that point. Right? Note down. Are you clear? So we'll go to next part. Now we'll see local maxima and local minima. So, here decreasing, here increasing, and here decreasing, and here increasing, and here decreasing, and here increasing. See the function, it is decreasing and here it is increasing. Again from here decreasing, here increasing, decreasing and here increasing. So here P, Q, R, S, T. Okay. Now you can see from the graph, what you can say, the turning points P, Q, R, S, T. Where you are calling the turning points, the function has a change, decreasing to increasing, decreasing to increasing, like that. Okay, where the function changes from with increasing to decreasing, vice versa, right, has valley and peak points. So this is the valley point and this is the peak point. Again, valley point, peak point, valley point, peak point. Like crest and trough in physics also you'll use it. Okay, right? Are said to be. Okay, then these turning points are said to be points of local maxima or minima, as f dash x changes sign due to the monotonic. This is called the monotonic increasing or decreasing nature of the function. Okay, these turning points are to be points of local maxima or minima as f dash x changes sign due to the monotonic increasing or decreasing nature of the function. So these are the critical points, and what you can say, P, R, and T points, P, R, T are local maxima points or local minimum. And points Q, S are local maximum points. So there are Q and S are maximum points local, and P, P or T are called the local minimum points. Are you clear? So understood now? If a function is said to be monotonic increasing or is a combination of crest and trough, like a simple harmonic motion or a progressive curve like that. So it has increasing and decreasing function. At each point of change of increasing to decreasing, there is a turning point. The turning point acts as point of local maxima or point of local minima. Depending upon the change in sign, positive to negative, it is maximum point, negative to positive, it is minimum point. Are you clear? So here every point is called a turning point or a critical point or a limiting point, like that. So in the specifically given points of the function P, Q, R, S, T, P, R, and T are called the points of local minima. Q and S are called the points of local maxima. And F of P, F of R, F of S. So these points correspondingly, this and this and this, they are said to be points of local minima, and this is called the points of local maxima. Are you clear? So respective points similarly also F of P, F of R, F of T are maximum value, minimum values, and F of Q, F of S are maximum values. Okay, so note down. You understood now? Still, we'll solve the problems. This is geometrical interpretation. I think you are already clear with this. What is maxima? What is minima? Points of minima, points of maxima, all those. Note down. Okay, noted? Yes. Note. Every monotonic function that is either increasing or decreasing a maximum or minimum value in the interval. In its interval. Okay. Similarly, every closed function, closed interval of a function has both maximum and minimum value and every open interval has neither increasing, has neither maximum or minimum value. Now see here example. For every modern increasing function or decreasing function, the function has maxima or minima. Because like it can come like this, curve, anything, it has minimum. Closed interval if I take here, 1 comma 2, so it is inclusive. So minimum value is 1, maximum value is 2, clearly. Suppose 0, 1, no maxima, no maximum value, and no, because 1 is 0 is not included, we don't know the least value. 1 is not included, we don't know the highest value, and no minimum. Suppose 0 and 1. So minimum value is how much? 0, no maximum. Right? Now if I take here 1, comma 2, no minimum value because and maximum value is 2. Are you clear? So likewise it will come. So depending upon the nature of the interval of the function has either maximum value or minimum value. If we are closing interval, both will be there. Right, see here, it's both open, no maximum, no minima. One side open, left open, no minima, right open, no maximum. Are you clear? Likewise, note down. Okay, clear? Now, we'll see an example. Find the maximum minimum value of f. If any of the function given by f of x is equal to mod x belongs to R, also find maximum value in minus 2 comma 1. Now plot the graph. Minus 1, minus 2, 1. Minus 2 also 2 will be there. And minus 1 also 1. And 0, 0. And 0. Because the value is minus 2 to 2 and minus 1. Right? Now this is the question. Okay. Now we'll see the answer. Solution. Given f of x is equal to mod x greater than 0 for all x belongs to R. Therefore, the minimum value is 0 and no maximum value. If domain of f is R. If I take without domain, if the real numbers domain, then what happens is greater than or equal to 0. Mod x is greater than 0 only automatically. So least value can be 0 and maximum value can be no maximum value because it can be any value. Minus infinity becomes plus infinity. So no maximum value and the least is open interval. Right. Now coming to the domain, if the x belongs to minus 2 comma 1, then the maximum value is f of minus 2 which is equal to mod minus 2 is equal to 2 and minimum value is what is the minimum value? You can take, tell me. And we have no minimum value. The minimum value is 1 you cannot take because minimum value is in between minus 2 to 1 0 also there. Right? So between minus 2 to 1 is 0 also there. And what you can say? So no minimum value. Maximum value will be there, minus 2 to 1. So understood now? Here minimum value is 0, no maximum value. Here maximum value is 2, get minus 2. So point of maxima or point of local maxima is minus 2 and local maximum value is, you understand the difference? Mod minus 2 which is equal to 2. You understand the difference of point of local maxima and maxima, local maxima and point of local minima and minima also. Now we have seen the theory, we understood what is maxima, local minima. Generally maxima and minima is called local maxima and local minima. At the same time, where the point of local maxima or point of local minima as well as local maximum value and local minimum value exist. That also we have seen. Geometrically we understood what is increasing function, decreasing function. The knowledge of increasing function and decreasing function we are using for the case of maxima and minima. You know, increasing function is f dash x greater than 0. Decreasing function is f dash x less than 0. At the point of local maxima, the sign of the function changes from positive to negative. And at the point of local minima, the sign of the function changes from negative to positive. Every monotonic function either can be increasing or decreasing. You should have extreme values. Extreme values are nothing but point of maxima or point of minima. The x value is point of maxima or point of minima, and the corresponding f of x or y value is nothing but local maxima or local minima value. We have seen geometrically with respect to open interval, one side open, one side closed, both open, both closed, how the maxima and minima exist. Geometrically we have verified, we understood what is it, increasing function, decreasing function. Then we are going to have the test or the mechanism for finding the maxima and minima of a given function. There are two ways of doing it. One is first derivative test and second one is second derivative test. Like how we have done for increasing function, decreasing function. With respect to neighborhood, C divides the total functions neighborhood as C minus H to C and C to C plus H. So left hand neighborhood, what is the nature of the function with respect to maxima, and the right hand neighborhood, what is the nature of the function with respect to minima or maxima. We are going to check. Then we use the principle or mechanism by using the first derivative test how to find the maxima and minima, and then second derivative test, the short method to verify. Depending upon the function, we apply first derivative test or second derivative test. Then we'll go for the applications. So that part we'll discuss tomorrow. Just this is a theory. Go through the NCERT textbook of this part. Then you will get the clear idea. And I think you are doing the revision also for examination. From next week, exams are there. Syllabus already you know. I have sent you revision worksheets, exemplar and textbook with any reference book is maximum. And you have any doubts, you can keep contacting me with your doubts through WhatsApp, and I will be sending you the solutions also. If you need explanation as a group, again you can ask me in the class also, so it will be clarified with that part. And have collaboration, and if possible, peer communication with respect to subject also is encouraged with the best way. And any problem, you don't keep it awaited till the exam carries out. Approach me by any means. You are accessible, so take the advantage, and still you have time for 1 week. I am not giving you everyday homework, so carry on with this part and the revision also together. Hopefully we will be completing this topic by this end of the month with a disturbance of 1 week for examinations, and with this differential calculus will be completed. We are left with one unit, which is integral calculus, maybe from the next month to start. One more point to be noted, we are not missing any part for your keeping in view or place of the company examinations also. I am covering deleted part also. That is your advantage, so make use of that part. Okay, because we are going at a standard rate of coverage from the day one, and we have a lot of time to cover. So make use of this best practice and carry on practice every day. So thank you all. We'll continue tomorrow.